Welcome back, everybody. In this video, we're going to look at how we find domain and range from continuous graphs. Now, what makes a continuous graph different from a discrete graph is that instead of just being a set of points graphed on the coordinate plane, we actually have curves or lines or whatever the case may be, where all the values are hit instead of just individual values. And so when we write these, instead of writing them as sets of ordered pairs, we're going to write them as inequalities or intervals. And in this video, we're going to talk about both inequality notation and interval notation. I personally prefer interval notation, but some people like to write them as inequalities. Now, we're going to write them that way because there are actually an infinite number of possible values in the domain or range. And so we need to get all of those infinite values instead of trying to list each individual one, because certainly we can't list every one. You know, if a graph passes through all the points from 4 to 5, we can't list 4 and 4.0000000000001 and, you know, all those different values, and so we need to write them as intervals or inequalities. As far as the notation for these, there are situations where we will use either less than signs, greater than signs, or less than or equal to signs, greater than or equal to signs when we're writing inequalities. And with intervals, we'll either use parentheses or brackets. And here we outline the way that we decide which sign to use. If we have a value that is a boundary of an interval, but it isn't actually part of the interval, okay, this is where we'll see maybe open circles on our graphs, or an asymptote maybe, you know. When we see those, we're going to use either less than or greater than signs with inequalities, and we're going to use parentheses with intervals. If we have a value that's a boundary and is included in the interval, then we're going to use less than or equal to, greater than or equal to signs if we write inequalities, and we'll use brackets if we are writing it as an interval. And one other point, sometimes we have graphs that go continue on all the way to the left or all the way to the right. These graphs go to either infinity or negative infinity. Those are never included as endpoints, so they will always be parentheses when they're in interval notation, or strictly greater than, strictly less than signs if we're writing them as inequalities. All right, let's look at a few examples. We're going to identify the domain and range here in part A. So the domain is all of the x values that this graph passes through. And so I'm going to move across this graph from left to right and identify all the x values that it passes through. Now if you look like over here to the left side of the screen, there are no points on this curve over to the left off of the graph. And so as I read this graph from left to right, I'm looking for the first place where a point occurs on this graph. And that happens right here as I'm reading it from left to right. I want to identify where that is because that's going to be the first endpoint of our interval for domain. And now as I continue to read from left to right, there's points on the graph, there's points on the graph, there's points on the graph, keep reading, there's still points on the graph, all the way until I get over to here. And after that point, there are no more points on the graph as I read it from left to right. And so my domain is going to be represented by all the values between these two. And I can write this as an inequality. It starts at -4. At -4, there is a point on the graph, so we're going to use a less than or equal to. Domains are represented by x values. And it keeps going all the way over to +4. And so there's what the inequality looks like that represents this domain. Now if I were to write this in interval notation, I would want to use brackets since the endpoints are included in the interval. And that is what the interval would look like in interval notation. All right, next, range. Now range, we're looking at the y values, so we're going to read this again, just like we did with the discrete graphs, from bottom to top. We find the first place where there's a point on the graph, reading it from bottom to top. It happens right here. And we keep reading, there's points on the graph, there's points on the graph, all the way up to here. And after that point, there are no more points on the graph. And so our range is going to be this interval here, all these values between these 2 points. This lowest point is at -3. There is a point on the graph there. The range is represented by y values, and it goes all the way up to and including +1. So there's our range. If I wanted to write that in interval notation, it would look like this: -3, 1, with brackets at the endpoints. Okay, moving on to example B. We start by looking at the domain, and so we read this graph from left to right. Well, you notice over here, at the left end of the graph, there's an arrow, which means that this graph continues to go forever in this direction. And so the domain starts as far over to the left as we can possibly put it. And the farthest to the left that we can possibly put it is at -infinity. And now the graph has x values. As I read from left to right, it keeps having x values all the way that I can see on the graph. And we've got this arrow at this end, which means it continues to go in this direction. So the graph continues going as far as it can to the right as well. And so it's going to go all the way over to +infinity. And there's the domain in inequality notation, or in interval notation, -infinity to infinity. All right. Range are our y values, which we're going to read from bottom to top. Now again, these arrows that go down here mean the graph keeps going in this direction. The left arrow here means the graph goes forever to the left and forever down, since it's angled down and to the left. The arrow on the right means that it goes forever to the right and forever down, since it's angled down and to the right. Well, what that means is that our range here is also going to start at -infinity. And if I look at this y value, I keep having points on the graph until I reach this point right here. At that point, there are no more points on the graph when I'm looking at the y values. And so that's going to be the top end of our range. That's at +3. There is a point on the graph there, so I'm going to write it as less than or equal to. And there's what my inequality notation looks like. Or if I write it as an interval, with infinity with a parenthesis, 3 with a bracket. Okay. A couple more examples. These are a little bit more complicated. Let's start with A. And we'll start with the domain, which we're going to read from left to right. Well, if you look at this graph, again, you see that over here it continues to go forever to the left. It also continues to go forever to the right. And all the values on this graph are hit, all the way over here to x equals -1, and then there's an open circle, and then the points pick up again. But since this solid circle and open circle are lined up, that means that that point is in the domain, and so every single x value is in the domain from -infinity to infinity. So if I write it as an inequality, -infinity is less than x is less than infinity, or if I write it in interval notation, using the parentheses. Now as far as the range goes, the range is a little tricky here compared to the last couple. I'm reading the range from bottom to top. Well, there are no points on the graph down here at the bottom. And the first time that I encounter a point on the graph is right here at y equals 2. And then there's a gap. And then I encounter points again right here at y equals 4. And so, even though this graph is continuous, the range has distinct values in it. So I'm going to write it like a set, just like I wrote the sets when I was writing discrete graphs. And so my range here is going to be the set. It contains 2 and 4. Those are the only y values that appear on this graph. So that's going to be our range. All right, part B. Domain. We're reading it from left to right. Let's see, it starts right here at x equals -4. And there's a point there. And it goes all the way over here to -1, but there's not a point there. I'm not going to include that. And then it starts up again to the right of -1 and goes all the way over here to +2. Now there's a symbol we use. It's a little U shape. Doesn't have the tail like a lowercase u, but it looks more like a little parabola opening up. And then we start up at -1 and go all the way over to 2. If I wrote this as intervals, it would look like this: -4 to -1, union, -1 to 2. That's what that little U symbol is. It's a union symbol, which basically means or. And so the x values that are on this graph are from -4 to -1, or from -1 to 2. All right, now the range. We're looking at this from bottom to top. And the first point we encounter going on the graph from bottom to top is right here at y equals -2, which is a point on the graph. And then we have points on the graph for all these y values, still points on the graph, all the way up here to 4, where there's an open circle. So 4 is a boundary, but it's not included, so we use a less than sign. Now writing it as an interval, bracket, -2, 4, parenthesis. And these are ways that we can write domain and range from continuous graphs. Obviously, there's really infinite possibilities as far as what we can see with the intervals that are the domains and ranges of the various graphs. And so one of the best things that you can do is look at a whole bunch of graphs and try to identify the domain and range and see if you do it correctly. All right, that's it for this lesson. See you next time.